What I'm about to do is I'm about to teach you what happens when you have to start applying the arithmetic and geometric sequences and series knowledge that you know. Like, what actually happens in your brain when you see a problem on the test for the first time? And then if I don't tell you on the test what kind of pattern it is, how do you know what to use? Well, what I'm going to do is I'm going to create a flow chart, a kind of logic flow chart that you could use to help you figure out what you can do on a test. So the first question that you must see anytime you look at any problem, you're going to ask yourself, what's the pattern? This is where you start. If I give you a list of numbers or if I give you a formula, you have to determine what is the pattern. Now, luckily, there's only two choices. So if you test for the first choice and you fail, then you can actually go to the second choice. Because due to the binary situation of this, there's only two options. So if the pattern is not addition or subtraction, then the pattern is going to be multiplication division. Now, I'm going to quickly erase the division because in our geometric patterns, we don't use division. We consider R as a ratio. That can be a fraction, a decimal, it can be a whole number, integer. So we're going to treat this as a multiplication pattern because that's how we set it up. So an example of an addition or subtraction pattern would be like the numbers 3, 6, 9, gesundheit, and 12. And this tends to be an addition pattern. It's going up by 4 each time. This is another addition pattern, 8, -2, -12, -22. This is another addition pattern where it's going down or using subtraction. You can have patterns where a sub n is equal to something that looks like a slope equation, 2n plus 4, or have this with a sigma in front of it, where I ask you for a certain term to a certain end and add all these up. This is an example of all the addition and subtraction patterns. They're not all of them, but there are a few of them that will look common. In terms of the geometric, so if you're looking at the patterns and you're seeing an addition or subtraction, then hey, we're in the arithmetic world. All right? So we're now in arithmetic patterns. But what happens if you get a list of numbers that doesn't follow that addition or subtraction pattern? So 1, 5, 25, 125, and so forth. Well, the gap here is not the same each time, so by default, it is not an arithmetic pattern. This is geometric. So when you see a pattern on the test, you look for the arithmetic, and if that fails, you go to geometric. Also, this is another geometric pattern, 4, 1, 1/4, 1/16. As you see, this is getting smaller each time, but it's getting smaller with a geometric pattern. And then here's another one. Here's 8, -4, 2, -1, +1/2. But you might actually look at these patterns and go like, okay, I absolutely know that these are not arithmetic. By all means, these are definitely not arithmetic. But what are they moving by? Well, what's cool about the geometric patterns is they have a pretty set ratio formula where you just take two terms and divide them by each other. And I usually pick the two terms that are at the start because they're usually the easiest numbers to manipulate. So 5 over 1, so this is a sub 2 over a sub 1. So 5 over 1, the R value or the ratio is 5. 1 over 4, so the ratio here is 1/4. -4 over 8, the ratio here is -1/2. And you can see that multiplying by -1/2 has this oscillation. Hey, you know what's cool about these oscillating patterns? Not arithmetic. Like you can't do that very well with an arithmetic pattern. So this is a dead giveaway for geometric. So now you've identified what's the pattern and you've identified where you need to go. Well, what you would then need to do is you need to figure out, what am I even asking for? You know, am I asking for the a sub n? Or am I asking for the sum? You know, what am I asking for? The a sub n or sum? And that's a sigma. It's a sigma. I know it's a little sloppy here. But the a sub n, if you're going to need the sum and it's an arithmetic, then you're going to use your arithmetic sum formula, which is a sub n is equal to a sub 1 plus n minus 1 times d. And that's for finding an nth term of a problem. And you would need to identify your a sub 1, your first term. You would need to identify your distance and what term you're going to. Here, this is the sum, and the sum formula is S of n is equal to n divided by 2 in parentheses a sub 1 plus a sub n. So you need to know your first term, your last term, and you need to know how many terms you're going to. So that right there fits all the things you could use for the arithmetic. Now in geometric, all right, again, if I ask you for a sub n, because these are the two things you're going to get. You're going to get a geometric pattern. Am I asking for a sub n? If I'm asking for a sub n, you have to use the a sub n formula, which is taking your first term, a sub 1, and raising it r to the n minus 1 power. Now, what about the sum? Well, now, these sums are going to be finite. These sums are going to be finite sums. And you're going to see that because it's going to be a number on top of the sigma that tells you it's finite. Or it's going to tell you like the 20th term or the 15th term or the 5th term. So this would then be the sum of n is equal to a sub 1 times 1 minus, little sloppy there, 1 minus r to the nth over 1 minus r. That's a sub 1 times 1 minus r to the nth over 1 minus r.
It was at this moment that he realized that he messed up. The n of this equation should not be on the outside of the binomial. It should in fact be by this r right here. The correct equation is a sub 1 times a quantity of 1 minus r to the nth divided by 1 minus r. This is not the correct placement for that variable.
So this is for finite geometric sums. Now, infinite geometric sums will literally say, find the infinite geometric sum, or there would be an infinity above this symbol, and those have a different formula. In fact, it's this formula, a sub 1 over 1 minus r. It doesn't have the 1 minus r to the n, because that goes to, the r goes to 0, and okay, we talked about that in a previous video. Okay, so what happens if you're outside the triangle? What happens if you're outside the triangle? Because you might have a problem that's outside of the triangle. And let me tell you when it's going to show up. If you see a sigma that has a linear equation, this is arithmetic. Another way to look at it, if you see a sigma that has an equation without exponentials, this is arithmetic. If you see a sigma that has some kind of power to it, then you are in geometric. In fact, if you don't even see the sigma, if I just ask you to go to the nth power, that's geometric. So geometric has exponentials. Arithmetic does not. And there's one more situation. There's one more situation. What if it has both? What if the equation that I give you on the test has not only exponentials and linear at the same time? Well, then you can't use any of this. Here's a perfect example. If I want the sum from the second through the sixth term of the equation denoted by 3n squared plus 4, this equation is no longer either arithmetic or geometric. It actually doesn't fit into any of these shortcuts. And when you can't fit this into a shortcut, you know what you got to do? You got to do it the long way. You got to actually take 2 and plug it into this n and figure all this out and get the answer for a sub 2. Okay? And then you're going to plug in a sub 3. Plug in 3 into this equation and figure that out. And then plug in 4. And then plug in 5. And then plug in 6. And that's where you stop. The number at the top tells you where to stop. The number doesn't tell you quantity of terms. The number tells you when to stop. And there it is. You stop at the 6th term, which gives you 5 numbers to add up. So everything in this triangle has been made to make your life avoid this situation, which is doing it the long way, writing it all out. So that's why we use these formulas to do horrendously long problems in a very short amount of time. Because if this shows up on your test, that top number will not be in the double digits. It will not be 20, 30, 40, or 50. However, if anything else is on this test, you can expect some bigger numbers that would be essentially silly to do by hand. You're going to want to, do it out and show all your work on the test. But this is your flow chart. To review before we end this little session here, you're always going to figure out what the pattern is first. Try addition and subtraction patterns, and it has to work for every term along the way. So even if it works for 3 terms but fails on the 4th term, it may not be arithmetic, or you may have made an addition mistake. So please check, and then if it doesn't pass the arithmetic, then do your a sub 2 divided by a sub 1 to get the ratio for geometric. And then analyze, what am I doing? Am I getting an nth term or the sum? Getting an nth term or the sum? And then that will be put into the formulas there. So hopefully this will help, and good luck on synthesizing all this as we bring this to a close in this chapter. Thank you.